This demo shows the concept of file integrity monitoring, FIM. FIM is used to detect changes to important system files. I'm first going to show you this function called calculate checksum. Now, this function calculates a simple checksum for a file. It takes input a file pointer to an opened file, and then what it does in the middle, or what the function does, is it reads the file character by character and adds the values. And then it returns a number representing the file's checksum. If the file contents change, the checksum will also change. So real systems typically use stronger hashes like SHA-256. So let me show you the main. The first thing is we open the file we want to monitor. And then the file that we want to monitor is called important.txt. And we open that in read mode, and this is the contents of important.txt. It says this is a protected system file. We then calculate the baseline checksum of that file using the calculate checksum. And we store the returned value in baseline checksum and display that to the user. And then what we do is we check if the user modified the file. We'll open it again, calculate the checksum one more time, and then store the value in current checksum and display that value to the user. We then compare if the baseline checksum before modifying is not equal to the checksum after modification. We say if they're not equal to each other, then we say integrity change has been detected. Otherwise, no file changes has been detected. So let me show you how this works. I'm going to run the program. Now the baseline baseline checksum is 2972, and I won't make any changes to the file, and I'm going to enter to check integrity. Now the current checksum, that the recalculated value, is the same as the initial value. So here the baseline is okay, and we say no file changes has been detected. I'm going to run one more time, and this time I am going to actually make changes to the file. So initially we have that baseline checksum 2972. Now I'm going to remove that dot and I will save. And then coming back to the program, and then I'm going to hit enter. The recalculated checksum is 2926, which is different to the original value. So here we get the first condition, which is integrity change has been detected. So what we basically did is, if we come back to the beginning, the program first creates a baseline checksum of a file. Later, it recalculates the checksum and compares the two values. If the values are different, the file has changed. So this is how we detected changes to important system files. Of course, this is done at a very simple level, but in real tools such as Tripwire or OSSEC automatically monitor important files and alert administrators if changes occur. I hope this video was helpful to you, and I'll see you in the next one. Thank you for watching.